Hey, 6th grade, here we are again with our next lesson, 87 multiplying algebraic terms. Again, this is one of those titles that sounds really scary, but once we get into it, you'll see that it is not as scary as it makes it sound. Well, we worked with algebraic terms a few lessons back, and we worked with combining them. That was that lesson where we talked about polynomials. Remember that word, polynomials? So our polynomial, if you remember, is just an expression with algebraic terms. And we have our monomial, our binomial, and our trinomial. Remember those root words are mono, bi, and tri. Our monomial, meaning it has one expression, binomial, meaning two expressions, and trinomial, meaning three expressions. Hopefully this is coming back to you right now. So here are some examples of polynomials. X squared is a polynomial by itself. It is also just a term. X squared plus 1 would be a binomial because it has two terms in the expression. The x squared is one term and the 1 is one term. The trinomial is a polynomial with three terms, the x squared, the x, and then the 1. Okay, so hopefully that is all back in your memory. Now that we remember what our polynomials are, you can remember that we talked about collecting the like terms or adding the like terms. And over here, you can see the book is discussing this, reminding you of this. This is the Chuck Norris video on Khan Academy. Go ahead and Google that later if you're able to. You can Google Chuck Norris on Khan Academy. And it's the idea of saying if you have 3 Chuck Norrises and you have 2 more Chuck Norrises, then you will have 5 Chuck Norrises. It's the same thing you did when you were learning how to add in kindergarten. If I have 3 apples and then Bo brings me 2 more apples, then together we have 5 apples. So they have us with 3x plus 2x's equals 5x's. Remember that with this, if I have 3x plus 2x equals 5x, 3x plus 2y, remember, that just equals 3x plus 2y, right? Because these are not like terms. Those are completely different terms, right? The x is being multiplied by the 3, the y is being multiplied by the 2, and this plus sign keeps them apart. Okay. So now let's look at multiplying terms. This is a little bit different and honestly a little bit easier. Okay, we're going to be multiplying these terms. So I've set up the problem. In blue circled is what it looks like in your book. Okay, but here's the problem. 3x multiplied by 2x. Let's look a little bit closer at what this is telling us. Okay, it's telling us that we have 3x multiplied by 2x. Okay, well, we know it's multiplication, and we know that with commutative property, we can move these things around. With associative property, we can regroup. So because of that, we can take out the 3's and the 2's and the x's, and I can say, well, I have a 3 multiplied by an x multiplied by a 2 multiplied by an x. Because all of these things are being multiplied together. The x is being multiplied by the 2, is being multiplied by the 3, is being multiplied by the other x. The parentheses next to each other means that everything is being multiplied by each other. Okay? There is no plus sign or minus sign interrupting this flow of multiplication. So now that I have this flow of multiplication, I have this 3 times x times 2 times x, I can regroup here, I can look at this and I can say, well, I've got my 3 and my 2, those are pretty easy to multiply together. I'm going to put them next to each other. And I've got these 2 x's, they're kind of easy. I'm going to put those together. And now let's see what we get. Well, 3 times 2, I know what that is. That's 6. X times x. X times x. Well, you should know that from when we square things, right? A foot times a foot is a foot squared. A centimeter times a centimeter is a centimeter squared. So an x times an x is an x squared. So our final answer is 6x squared. 3x times 2x gives us 6x squared. Okay, so side note here, our little answer here, this is a polynomial. In of itself is a polynomial. This polynomial would be what? A monomial, binomial, or trinomial. If you said it has one term, so it's a monomial, you are correct. Okay, so before we move on to our first example, we're going to turn the page over and I want to talk to you about multiplying these terms when our variables are not alike. What do we do if we have an x and a y as opposed to them both being x's? And the book gives us a little example of that. We see that right here in our book. So let me show you what we do in that case. Okay, so here we have negative 2x multiplied by a negative 3y. So they're throwing negative signs at you now. Okay, so again, this is just negative signs. They're not saying that we're subtracting anything here. They're just saying that these are negative numbers being multiplied by each other. Okay, so because of our commutative and associative properties, we just pull out what we want to pull out and reorder them, right? So I'm going to have a negative 2 multiplied by a negative 3 multiplied by an x multiplied by a y. Negative 2 times negative 3. 2 times 3 is 6. A negative times a negative is a positive. So now we have a positive 6. So that gives us a positive 6, right? X times y. Well, there's nothing else we can really do with that. It's just x times y. Okay, so this area right here just becomes x, y. So our final answer becomes 6x, y. Just like that. And so now we have our new term, our new algebraic term. Okay, so now let's talk about example 1. Here is a long one. Okay, here's a very long term that we need to simplify. Okay, notice there's no equal sign, right? This isn't something we are solving, right? Please remember this always. The direction says to simplify, right? We're not solving for anything. We're not solving for x. We're not solving for y. I should never see x equals or y equals when there's a problem like this, right? We're simplifying. We're taking this really, really, really long problem, this really, really long term, and we're condensing it. We're making it as small as possible, okay? Because this is a really long multiplication problem that we need to make smaller. Okay, so let's do that. Let's make this smaller. So first, let's look at these terms we have. We have a -3. We have a 2 and a -4. We have an x squared, an x, a y, and a y. So those are some of the terms that we have here. So let's start pulling some of this stuff out so we can start working with it. So we have a -3. We have an x squared. What does an x squared mean? If you're saying that it means that I have an x times an x, then you're right. So I have x and x, and I have a y. Then I have a 2 that's being multiplied. And then another x. And now a -4. Oops. And now another x. And now a y. Okay, so I've pulled everything out of there. So I have -3 times x times y. So that's this first group. Then a 2x. And then a -4xy. So I've pulled all these groups out and just made them one long multiplication. Okay, now I'm going to regroup. I'm going to regroup them. And notice how I was doing these different colors? I did different colors to kind of make it easy for you to see how I'm going to regroup them. Okay, I'm going to take all of my integers from our last lesson, right? My integer families, I'm going to take all those and I'm going to group those together. So I like this -3. I'm going to take a -3 and a 2 and a -4, and I'm going to multiply those together. Then I like that I have these x's here. I'm going to multiply all those together. So I have x times x times x times x. And then I have 2 y's. Y times y. Now it's a little bit easier for us to see what we have. Well, 3 times 2, 6, times 4, 24. Let me go back there a little bit. -3 times 2. -6 times -4. Now we can look at it. -6 times -4, positive 24. Do you see how I did that? -3 times 2 gives me a -6. 3 times 2 is 6. A negative and a positive gives me a -6. Then I take my -6 and multiply it by my -4. 6 times 4 is 24. And a -6 and a -4 gives me a positive 24. Now, how many x's do I have? 1, 2, 3, 4. So I have x to the 4th power. I have 2y, so I have y to the second power. And that is my final answer. Okay, so this is a much longer lesson than yesterday, so I want you to pause here, go to the Google form for practice set, and do A, D, and E. The practice set is for completion points, so you will get feedback, immediate feedback on the practice set when you do it. So pause here, do A, D, and E, and then come back, and we will finish the lesson. So go do A, D, and E, come back, and finish the lesson. All right, welcome back. Hopefully you found the practice set helpful and you figured out your mistakes, or you figured out how to do it, and you are learning this well. If you are struggling and you are needing some extra help, please ask questions in the comments or private questions. Let me know what I can do to help you. Please ask specific questions. If you say, I just don't understand, or can you help me? I want to, but I need to know what specifically you are not understanding. So at what point in the video did I lose you? Things like that. Okay, moving on. Example 2. Okay, so here we have negative 2ab multiplied by a squared b multiplied by 3b cubed. Okay, might look scary, but it's not. We're going to break it apart and we will be okay. So let's first look at our first term here in our parentheses, right? We have a negative 2 multiplied by an a multiplied by a b. Then we have a squared. Well, an a squared is just an a times an a, right? So a times a, and then we have a b. Followed by a 3, so times 3, and then we have a b cubed. Well, b to the third power is b times b times b. So now let's regroup these. Let's look at our numerical values, or our integers, okay? I have a negative 2 and I have a 3. That's all I have, right? So let's group that together. I have a negative 2 and I have a positive 3. Now let's look at our variables. I have an A, an A, an A. I have 3 A's. A times A times A. And then I have some B's. B, 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 B. So I have 1, 2, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 2 times 3, 6. Negative times a positive, negative. Negative 6. A times A times A. 3 A's gives us A to the third. B times B times B times B times B. 5 B's gives us B to the fifth. Final answer. Negative 6, A to the third, B to the fifth. All right, go do practice BCF in the Google form. pause this, go do the practice, and come back when you are ready. All right, welcome back, and we are finally on the last example. Okay, -3a squared b cubed all raised to the second power. Okay, there are two ways to look at this problem, and we will go through both ways. First, kind of a simple way to see it, but is more work in the long run. But simple way to see it is to look at it as one long multiplication problem. So you can see that I've got -3a squared b cubed multiplied by -3a squared b cubed. It's just the same term, right? Because it's multiplied by itself. It's squared. Then I take out the terms and multiply them. Okay, I'm going to do this faster because now you have practice. I have a -3 and a -3. I have a's, right? A times a, right here, and another a times a right there. And then I have some b's. 3 b's over here. 1, 2, 3. And then 3 b's over here. 1, 2, 3. Okay, so now I can solve them. 3 times 3, 9. A times A times A times A. That's 4a, so a to the 4th. B times B times B times B times B times B times B. That's 1, 2, 3, 4, 5, 6 b's. B to the 6th. And there's my answer, 9a to the 4th, b to the 6th. Okay, so that's one way to solve this type of problem. Let me show you another way to solve it. Okay, so here's the other way to solve it using our exponent rules, our power rule. If you remember that if we have an exponent raised to an exponent, you can multiply those exponents. X to the a raised to the b is xa times b. So we can do is we can separate these out and say that what I really have here is -3 squared, right? So I'm taking my -3 and squaring it, multiplied by my a squared to the second power, multiplied by my b cubed to my second power. And now I can solve all these. Okay, -3 squared. Well, a -3 times a -3. -3 times -3 gives us a +9. A to the squared to the squared. If we follow the power rules, that means a 2 times 2 equals a to the 4th. B cubed to the squared would equal b to the 3 times 2, which is b to the 6th. So we end up with the same answer of 9 a to the 4th b to the 6th in a much faster way.